Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother Joel. We're here to hopefully show you how to approach SAT math questions. Here's a sample question from what the SAT is going to call the digital SAT, which is going to start in the United States for high school students in the spring of 2024. They gave us 16 questions to practice with, and this is question number 5. Okay, question number 5. Figure A and B. Oh, they don't give us the figures, do they? Oops. Oh, that's not good. They don't give us the figures, yeah. Figure A and B are both regular polygons. Then the sum of the perimeter of figure A and the perimeter of figure B is 63. Aha. The equation 3x plus 6y equals 63 represents this situation. Ooh, okay. Where x is the number of sides of figure A and y is the number of sides of figure B. Which statement in this is the best interpretation of 6 in this context? Okay. Unfortunately, both Seth and I looked at the answer, which is really bad. Okay, so you got regular polygons. Regular polygons are like these things. Not that this is the answer, but these are regular polygons. Everything is the same in a regular, all the sides are the same in a regular polygon. So the sum of the...
And the angles are the same, too.
The angles are the same, but we don't really care less about the angles right now in this problem. So in no way do we care about that. But you're right, the angles are the same, too. Yeah, The sum of the perimeter of figure A and the perimeter of figure B is 63. Not that these are correct, right? These may not be the right polygons. This equation represents, okay, x is the number of sides of figure A, and y is the number of sides of figure B, and the sum is 63. Each side of figure B has a length of 6. The number of sides of figure B is 6. Each side of figure A has a length of 6, and the number of sides of figure A is 6. I don't know. So this is going. I would say we skip this question because we know the answer, and I would like to actually have thought it through, but I know it's A, so I would. What do you think we skip this question? Because we both know it's A.
Well, should we skip it? No, I think we should talk about it.
Okay.
Well, I think it's important. Approach SAT questions by reading the questions and then pull out what is most relevant. What's the important information? It's given in the question.
Okay.
It tells you what X is, tells you what Y is. And then it says that the equation represents the sum of the perimeters equals 63. So I take that to mean that that one term is the perimeter of one polygon, the other term is the parameter of the other polygon, and then it tells you that y is the number of sides in figure B. This term, y is the number of sides. Okay. The whole thing is the perimeter of polygon B. That's the whole thing. And, but the only thing 6 could be is the length of each side. That is the number that makes it true that that number times the number of sides is the perimeter of B. So 6 is the length of one side of B. And then that's what they say for answer A.
Okay, that makes sense. So it's weird because the 3 and the x have nothing to do with the problem, really.
That's right.
Yeah, so
Yeah, but yeah, three of the X have nothing to do with the problem, but what has to do with the problem is a situation of summing. This situation is that adding the parameters gives you 63.
right,
The equation is said to represent the situation. The equations represents adding of two things to be 63. The
right,
situation is adding of the perimeters. So each of the terms corresponds to one of the perimeters. But which one? And then they tell you. X appears only in the first term, and they tell you it's the number of sides of triangle A.
right, right. And notice they put this word best in as opposed to what statement is absolutely true, no matter what. I mean, there's a difference between that. There's an absolutely true no matter what. Which statement must be true? There's a difference, right? Which statement they could have said must be true, but they didn't do that. They said best interpretation of. Because isn't it some crazy thing where you could set this whole thing up where this is not actually true, but
yeah,
right? Because they're not.
Right.
They didn't tell you specifically what these are.
Yeah.
So that's what sort of threw me. Right? They didn't say must be true. They said best interpretation of. So, anyway. Okay.
Okay.
Fine,
well, in fact, let me think. Yeah. So, let's see. So this is true. 6 is the length of each side of B polygon. 3 is the length of each side of the other polygon, and we don't know the numbers of sides in each one. They're given by X and Y. So possible solutions. First, the X and Y have to be positive integers. Okay.
No,
so the solution.
No, they don't.
So the thing is, there might be multiple solutions, different combinations of X and Y that give you this property.
That's right.
It's what's called a linear. Should we try to find each one?
No. But we do have to understand that they didn't say must be true. It said best interpretation.
Can be, yeah. And in fact, I bet that we get psychologically they made it so that there are multiple solutions. I bet there are.
Yeah.
Should we see?
I don't think so.
Well, that's, the way you do it. It's easier to do by brute force.
Seth's hungry. Seth's hungry to do it.
I'm hungry.
By the way, today's Throwback Thursday, so if you have the patience to sit through this, we're going to do a question from a test from about...
Maybe we could do it after Throwback Thursday.
You want to do it after Throwback Thursday?
Yeah. Okay, I'm going to just write it down.
Fine. Okay.
3x plus 6y equals 63.
So...
Diaphantine.
Again, I apologize for saying that weird stuff at the beginning, talking to Seth about whether we should go or not do this. I'm glad, Seth, you decided that we should just do it even though we knew the answer. I always like to do it from scratch. It's more honest. Do it without knowing the answer. So I think better when I don't know the answer. But I'm glad Seth took it over and did it. Okay, Throwback Thursday. It is Thursday. So we go back to a test from about 2005. When it was more of a reasoning test than a test about knowledge, about math. So I already chose the question. Seth has not seen it. I haven't looked at it that much. But it is also a geometry question. Okay, so this question was from a test from about 18 years ago. The tests had a whole different feel to them. They had like 9 sections, and one section was a test section, which was never graded, but they never told you what section it was. And the test had a whole different feel to it. So anyway, here's a question from Seth. Pay attention. This is a question from this is our throwback question, Throwback Thursday question. Okay, here we go. It's geometry again, and it has to do with polygons. In fact, it has to do with regular polygons because these figures are equilateral. Okay. So you can please read the question, pause it, and come back if we're lucky enough to have figured this out. Okay, in the figure above, these two triangles are equilateral, and line segment AE is 25, so we could put that in, right? 25 for the whole thing. What is the sum of the perimeters of the two triangles? The sum of the perimeters. Oh, I see how to do it. Oh, I know how to do it.
That's easy.
You have to be smart, sort of. You have to see things without the tick marks, right? Okay. This thing plus double dot is 25, but then you have another set of those, right? Oops, you have another set of these, right? See, and then you have another set of these. Then you have another set of these, right? So it's 3 times. 3
I'll
times.
do it. I'll do it at the bottom. Okay, I'll do it at the bottom. You do it at the top.
3 times 35. Wow. So when I first looked at this, when I was choosing the question, I said to myself, "Oh, this is really hard." But then I just put the tick marks in, and the tick marks said, "Wow, oh yeah, there's a pattern here. This is more of a pattern question, isn't it?" Whoops, you're writing. Isn't this more of a pattern question than anything? Recognizing the pattern.
Don't move it around.
I'm done. What are you doing?
Well, I'm thinking, could people see what I wrote?
Yeah. Oh, these are tick marks. Seth's taking these. The one that 1 and that 2 stand for my tick marks. Right?
There are 3 of them.
Right. So it's not a 1. By the way, Seth's always the explainer that he never wants to have anything confusing. Everything has to be clear. But frankly, this looks like a 1 and this looks like an 11. Oh, wait. Yeah. That looks like a 1 and that looks like an 11, doesn't it? Well, that's a little confusing. So, anyway, I don't know. This seems more of a pattern question, doesn't it?
Well, that's all pattern questions. The way I saw it was that I saw Joel was very helpful in putting in the tick marks. And I saw that what they're asking for, the sum of the perimeters, is 3 single ticks plus 3 double ticks. I know what 1 double tick plus 2, I know what 1 double tick plus 1 single tick is.
Right.
And they're asking for 3 of each.
Right.
So you just take 25 and multiply it by 3.
Right. Okay. So, yeah, if you don't have now when I was searching for the question, which I try not to answer, I just sort of look at it to see if it's hard or difficult. It struck me as hard because I didn't put the tick marks in. But wow, magic happens when you put the tick marks in.
Yeah.
Because then you just realize this is a set.
So I could see that with the tick marks, you could see that 25 is this tick mark plus this tick mark.
Yeah, and I have to apologize because the screen froze, so people can't see it right now, but they will. Yeah, exactly. It's a pair. A pair of tick marks makes 25. You have another pair here. Yeah. And then you have another pair here.
Yeah, so a pair of the 2 kinds.
Right,
2 different kinds.
Pair of tick marks, right?
Yeah. So we have a triple of single ticks.
Yeah.
And another triple of double ticks.
Well, what we really have is 3 sets of a pair of a set of tick marks. So this really shows something about how to approach geometry questions. Tick marks. Tick marks, it cannot be said enough. If you have a geometry question, tick marks. Tick marks. Yeah. Approach. Talk about approach. Tick marks. Let the tick marks do the thinking. Last year I did a geometry proof where you basically do a lot of givens and you put down the tick marks. You put down enough tick marks, you don't have to do anything because the tick marks does all the thinking. He starts making a little tick. That's not funny if someone got bit by a tick, though.
No.
That's not funny if someone got bit by a tick, because that disease can be really serious.
Yeah, you
But
get
so we're not laughing about that. But if you put enough tick marks in a geometry problem, you can let the tick marks do all the thinking for you in a lot of geometry problems, particularly in geometry proofs. Oh, well, really any geometry problem. So, anything else to be said?
no.
No. Wow. So, Throwback Thursday. Now, do you think this problem could have been asked this year in the post 2016 tests? Maybe. Maybe.
Well, let me think. Let me think. Well, the one we, yeah. I think the last question we did was, I don't know. I think it's a guess at the level of difficulty. I think the last question we did for the sample question for the new SAT is on the same order of difficulty as this one.
Yeah. No, but the nature of the problem. The nature.
Yeah. The nature
Yeah.
of the problem.
Okay. Okay. So anyway,
Yeah.
now we promised everyone we're done with Throwback Thursday. We're basically done, except Seth wants to figure out if there's another
Yeah.
solution to that thing, that other problem.
Yeah, I think the other one was more the one we're going back to. The new one is more difficult
Right.
because the situation might the same situation might apply to different numerical features.
Right, which
Well,
we're going to talk about now. Okay, so let's let everyone go if they don't want to hear that. So everyone, thank you for watching. Please like us, dislike us, give us comments in YouTube, or email us at satmathquestionoftheday@gmail.com. And if you have any questions, any SAT math questions you'd like us to go over, please email them to us at that email address. And we hope to see you tomorrow. And now Seth is dying to find out whether there really are multiple solutions to this problem. And by the way, there's A. This is the answer, by the way. This is what they want you to do. And then they describe how to do it. Here we go. This is their explanation. So you can read it. Since 6y represents the perimeter in inches of figure B. Did they explicitly say that? They said that, right?
Y represents the number of sides of figure B.
That's no. Did they say that 6y represents the perimeter inches of figure B? Did they say that? Did they? They didn't say that.
They said that in the explanation.
Yeah.
And the explanation, this line is a consequence of what they said. It's given that both regular and the sum is 63. It's also given that the number of sides in A is X and the Y is the number of sides in B. And the equation represents this situation. And so they simply write the conclusion, right?
Yeah, they say thus, but they don't say
thus. Yeah, so this follows from these two statements, but they don't explain why.
But then, all right, it's not said in the question, right? They don't explicitly say that 6y is the perimeter of the second one.
Yeah.
They don't say that.
No, they don't.
So then, is it always true? They say
they say that the equation represents the situation.
Okay.
And the situation is given by the first sentence.
Okay.
So I take that to mean that the situation is what it says. The perimeters are added with getting a total of 63. Yeah. The equation has two terms that are added, whose total is 63. So shall we conclude that the only way you could have an equation with two terms added together equals 63, the only way that could describe a situation of two things added to get 63 is for each of the things to be each of the terms.
Yeah, but But I guess so. I mean, that's obvious. Come on, we're nitpicking,
But you
right?
could have, but what if they have this? What if they have this situation? Uh, what's the equation? It's 3x. Suppose they say 3x.
Wait.
Uh,
X is the number of sides of figure eight. They didn't say this. Wait. In the question, did they say that x is the number of sides of figure A? Did they say that in the
yes,
question?
yes,
They did? You
yes,
sure?
yes.
Oh, you're right. Oh, you're right.
Yeah.
They did. Oh, you're right. They did say that x is the number of
Yeah.
sides of
So,
figure A. Yes.
for approaching SAT questions, when they tell you X is this, that it is important to use in the question.
Okay, number of sides in A.
Yeah. That's the
Y
critical part.
is number of
Yeah.
sides.
And in school, when algebra is introduced in school, the teachers demand that when you use variables, use variables with letters, that you write down what each variable represents.
Okay, so then I guess this is always true. Thus, there's no way to argue that. In other words, is there any way to argue this statement? Thus, 6x and 6y represent the primitive integers of figure A and B, respectively.
Yeah.
So you're saying that is absolutely true, based on what they gave in the problem.
Yeah. True. Well, I could make this crazy interpretation.
Okay.
3x. Suppose there's a discount and a bonus. 3x might it represent the perimeter of polygon A with a bonus of 10 added.
Mm-hmm.
And 6y is the perimeter of polygon B with a deduction of 10 subtracted.
Right. Okay. Yeah.
That's a situation.
Right.
And the situation is consistent with the sum of the perimeters being 63. But you could have other quantities that are with made up relevance to the perimeters of the polygons that also add up to 63. You can always get numbers that add up to 63. Right. You have two numbers that add up to 63. You could always get two other numbers that add up to 63 by subtracting something from the first number and adding the same amount back to the second number.
So you're saying that this then can represent the perimeter of 1, and this of A, and this represents the perimeter of B.
Yeah. Well, what they say, they say X. No, however, I think it's really, so let's say a devil's advocate argument. Suppose 3x represents the perimeter of polygon A with a bonus of 10 added.
Yeah, I wrote that down.
Right. Now, however, they say X is the number of sides.
Okay.
Of triangle A.
Yeah, right.
Right?
X is the number of sides of polygon A, yeah.
The polygon A, yeah. X is the number of sides of polygon A. Yeah. And so is it possible for 3 times X to be the perimeter of polygon A with a bonus? Does that possible?
I don't know. Well, maybe we can fudge the 10.
Maybe
X is the number.
Each side has it could be each side has length 2, and the 3 represents Now, suppose maybe each side has length 4, right? And 3 represents the length of a side. Represents the length of a side minus 1. No, that doesn't. But
No,
then,
no.
yeah, no. So I think that nails it down. Even though 3x, they tell you that x is the number of sides,
Right. So then,
and 3x rep, so 3x and 6y are numbers that add up to the sum of the perimeters.
right. Yeah. Yeah. Yeah.
Right.
Yeah. 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 So I guess it is a pretty tight question.
Yeah. Yeah.
So it
Okay.
is.
So now, let's see if we could determine what the values of x and y are in this situation.
No, they don't give you enough.
They don't ask you. Can you? Does the situation determine the values of x and y? Is the situation possible?
Well, why? Wait, why? Yeah, no, they don't. No, they don't tell you what x and y are. When this is
They don't. I know, but is it possible to figure? Is it possible to say anything about what the values of x and y are from the data they give you?
I don't think so.
Well, can x be 100?
Oh! You're saying are there limits? Are there ranges? Yeah. Are there intervals? Are there constraints in x and y?
Yeah.
I know. I thought you said can you pin x and y down specifically?
Okay, let's see if we can.
Oh, you're saying that there are limits and they have to be also integers.
Yeah. So and perhaps we should also do high schoolers in a high school curriculum. Does a polygon with 2 sides make any sense?
No.
And a polygon with 1 side?
No, makes no sense. So
okay, so each of x and y have to be positive.
Right.
They have to be integers, and they have to be at least 3.
That's right.
So let's see if we could find x and y.
Oh, see some options. Maybe there may be more than one possibility for x and y.
Yeah. So let's see. We're interested in we know the question is any x and y so that x
I have to
and
just
y.
Give you space. Okay.
X and y are integers greater than.
We have it here.
Greater than or equal to 3.
We have it here. Yes, greater than or equal to 3. Yeah.
I'm writing it up here. I need more space. So do it down here. Okay. Integer.
Yeah, we know.
Well, no, we have to write it down.
Okay. Fine.
Integers. And have the property that, what is it? 3x plus 6y equals 63.
Right.
Okay, so this is an equation. And let's convert it. Let's simplify it.
Oh, you're saying
divide
by
both
3.
sides by 3.
Right.
And we get this equation is equivalent to x plus 2y equals 21.
Fine.
Now, can we see it?
Go up here. Start writing up here, please. Start writing in this area. Up there. Okay?
I don't understand which area is this area.
Up on top, where the blue, I put a big green thing. Okay? See the big green thing? Just start writing up there, okay? Do you see it? Do you see the green thing?
Okay. Yes. I can't write on the green thing.
No, I'm going to erase it.
Oh, thank you.
You're welcome.
Okay, so x plus 2y equals
Right.
21.
And remember, x has to be greater than
Don't.
3. Oops, sorry. Sorry.
And the question is find x and y that are greater than or equal to 3.
That's right.
And x and y are integers.
Right. We know that.
Okay, so
We know
2y, if y is, for this to be possible, 2y has to be even. Therefore, 21 is odd, so x has to be odd.
Mm-hmm.
Let's try if x equals 1.
X can't be 1. Has
Yes,
to be
it can. Okay, can't be 1. That's no good. Could x be 2? No, because x has to be odd.
Wait, why don't you
Can
write
x
down?
be 3?
Why don't you write down that x has to be even?
X could be 3.
Since you're
Let's see
writing
if
all
x
this
could be 3.
down, why don't you write down
3 plus 2 times something equals 21 is possible.
No, x must be
because we could make this side, this could be 18, and so y could be 9.
Okay.
Now, what about the next odd number for x?
Wait, so let's write down
5.
a solution. So you're saying 3, 9 works.
3 and 9 work.
Okay, give them a check.
What about 5? Well, solve this, subtract 5 from both sides, and we get
8.
21 minus 5 is 16. You could put 8 here. What about 7?
7, knowing 7, maybe 7.
Let's see. 7. That's 12, right?
No.
So I could put a 6 here. What about 9?
No. 21 minus 7 is... What's 21 minus 7? It's 14.
Okay, all right, good. 7. All right, so yeah.
All right, so there's a pattern.
Yeah, 21 minus 9 is 12, which is 2 times 6.
Right. So there's a pattern.
Come on.
So there are multiple solutions.
Yeah, I could do 11. 11 equals 11 plus...
Now, this is a mess. This is a real mess. Nobody can see it.
2 times 5. Yeah, 11 plus 2 times 5.
That is bad.
13 equals 2 times 3.
Oh, my God.
And I think we're done. Because if I go to 14,
we have a big problem here.
I'll need 2 times 1. And in high school, there's no such thing as a two-sided polygon.
Okay,
so there's a whole bunch of solutions.
Right. So the video just got completely screwed up, but you get the point. Seth started with 3, x and y, and you got 3, 5, 7, and what can x get up to? What's the highest value for x?
For x, the highest value for x is 11.
Okay, so these are the possible x's.
Yeah.
That give an answer. Okay, so
x could be 6.
Oh,
y could be 6.
Yeah.
Y could be 6.
So these are the only possible answers.
But it doesn't have to be 6.
Right. Okay, so there are 5 answers. There are 5 answers.
Yeah.
Okay.
So I don't know, dude. This is called a Diophantine equation.
Okay.
Now, is that part of the new SAT curriculum?
They're not even asked this part of the question. They just wanted to know what the significance of the 6 was in this question.
Well, the significance of a 6, the significance of 6 is that it is the value of x in one of many solutions to the situation.
No, they said what is the statement is the best interpretation of
the best,
6. The
best
6
interpretation of 6
in this context. Oh, you're saying that 6 has a second meaning.
Yes.
6 is the value of y when x. No.
6 is one of a handful of different possible values for y in this situation.
Right. 6 can also be an answer for y when x is something. X is whatever it was that gave x. Oh, wow. Yeah. So that's why they don't have this must be true. They have to have best interpretation. Right. Oh, wow.
Yeah, so B. So the thing is, the statement B, the number of sides in figure B is 6. Well, to say this number is 6 is different from saying that this number might be 6.
Can be 6.
So is 6 means that it's impossible for it to be something other than 6.
Right.
And can be 6 means that it's possible for it to be 6, and it's possible for it to be some number that's not 6.
Right. That's right. Yeah. So wow. So that's interesting. So y can be 6 under certain circumstances.
Mm.
Wow.
Yeah.
Well, I think.
And then in a situation where y is 6, x is determined.
Right.
Well, x must be, what is it? 6 times 3 is 18. X must be 3.
Right. Now, Seth, I love the way you very nicely, that was really smart of you, to notice that x had to be odd. So that's something that everyone should take note on. That see how Seth knew that x had to be odd? Because 2 times y has to be even, and they add to an odd number, so x has to be odd. So keep that in mind when you do problems.
Mm.
That would have helped you 15 years ago, and they tend to ask that question 15 years ago.
Oh, yeah.
Now
definitely. 15 years ago, they had Diophantine equations were part of the deal.
Yeah, they really, really wanted you to know that. Now, I call it number theory. Maybe Seth calls it analysis. But that's something to keep an eye on if you ever see that question like that. Okay, so I guess we really killed this question. I mean, we totally destroyed it. And looked at all the different possibilities around it. I doubt anyone has gone to this part of the video. Congratulations. I mean, I hope you got something out of it if you got this far. But I bet there are not that many people who watched the end of this video. But if you did, more power to you. Okay, everyone. Then we hope to be back tomorrow to do another SAT math question of the day. Okay, everyone. Take care. Bye.